Good afternoon and welcome to our webinar. The topic of today's webinar is how to deploy HANA workloads for half the cost in less than 5 minutes. My name is Eric Fitzpatrick. I'm the Director of Solutions Engineering at TidalScale, and wanted to go ahead real quick and give some ground rules. For the webinar, everyone will be on mute for the entire duration of the webinar. So feel free to let the kids scream, the dog bark. You won't have to worry about it being interrupting the webinar. You can ask questions at any time in the questions section of the control panel for the software. So as you run into those questions, you can go ahead and answer those in. And if I don't answer them as part of the webinar, I will address those at the end. We will have a Q&A session, and we'll try to get through as many of those questions as we can. Real quick introduction, my background. I've been in the SAP ecosystem for about 25 years. I've been an SAP customer at Procter & Gamble. I was an SAP employee where I was a platinum level SAP consultant for the professional services organization. And I was also a research fellow for SAP Labs. I spent approximately 10 years at a SAP managed service provider called Freudenberg IT, where I oversaw approximately about 10,000 SAP systems worldwide. And I did a lot of the engineering and architecture there. So I've been with TidalScale for about 2 years, and the way I got here, and hopefully is of some interest, is we were having some issues sizing and deploying HANA, and I reached out to SAP and I said, we're having some issues. SAP recommended that I talk to TidalScale. I took a meeting, and 3 weeks later, I quit my job and joined the company because I felt that what I saw was truly going to change the way HANA was going to be deployed. So I'm here today to kind of share my experiences. You don't all have to go quit your jobs, but I hope you get the excitement that I had. So what we're going to cover today, just in case you want to plan and see what we're going to discuss. First thing I'm going to do is I'm going to discuss what is a software-defined server. The second I'm going to do is I'm going to go through those the use cases. How does those, how do the software-defined servers match up with the sizing and HANA use cases? Basically, how are we going to use those software-defined servers to solve our SAP HANA problems? Of course, one of the questions we always get is how does it work? How does this, is it magic? Is it gnomes? We're going to do a technical deep dive, and I'm going to explain how our machine learning layer of our hypervisor solves the problem for us. Then I'm going to give a quick demonstration of creating a server, a software-defined server, where we hit a couple of other SAP use cases, for example, Sybase, SAP on top of Oracle, traditional ECC6 and other systems. And then we'll go into the question and answer section. So the first thing I want to discuss is why are we here? Why are any of us here discussing SAP HANA? I want to look back to 2008. Interesting time. 2008 is also just about the time SAP on VMware started coming out. And I believe that was 2009 when that really took off. And what we were looking at back then is the concept of a big server was 16 gigabytes, maybe 32 gigabytes, maybe a huge system was 96 gigabytes. That was gigabytes. What we're looking at now is a large HANA system is 48 terabytes, 72 terabytes. These are the very large systems. Still then, even a normal size system, a medium sized system is 1 to 2 to 4 terabytes. So what we've been seeing over the last 12 years is that the size of the memory required for our SAP system has just blown up just in 12 years. So in that same amount of time, we were counting on Moore's law. Every 18 months we get twice the processor capacity, we get more memory. But we really didn't get Moore's law. Moore's law is dead, never showed up. What we did get, and what I'll go through here, is that we did get 7x memory capacity. So we have a lot more memory. So, DIMMs have gone from 16 to 32 to 64, starting to get 128s more common, and 256 are coming out of the lab. The CPU performance, if I look at it, it's about 5x in the same amount of time. Gone are the heady days of the 90s when we had tons of CPU, 1 gigahertz to 2 gigahertz to 3, just jumping the gigahertz wars. And the one real laggard here is the memory bandwidth per core. When I look at 2x memory bandwidth, I now have twice as much memory bandwidth. That's great, but now I have 7 times as much memory capacity. So my population has grown by 7x, whereas my roads for the cars that population want to drive on is 2x. So what we see a lot of is memory contention there. And SAP has pushed a lot of effort and development on NUMA to try to stay off of that memory bus. So we'll discuss that briefly as well. So that's the problems, our database growth. That's the quote unquote solution, is what the hardware vendors have given us. So what does TidalScale do? Well, in TidalScale, we take what we're given by current 2 and 4 socket x86 servers, and we scale that up to meet the size of the SAP databases. So a quick intro to virtualization. In the next slide, we'll talk about the software-defined server. Let's look back. Again, if I look back at traditional virtualization, and again, I'm going to pick on VMware. Like I mentioned, they took off about 12 years ago in the world of SAP. What they did is they took a standard server and they sliced it up. That was great given the size of the systems that we were dealing with back then. We were able to deploy our operating system, the SAP system on top of that, the database, the central instance, or the primary application server for the younger people. And it was all about getting more value out of that server. It was about taking a piece of hardware and getting as much out of it as possible. That was great for small data. Nowadays, what we're looking at is this much larger data. So what does TidalScale do? TidalScale takes a group of servers, and what we do is instead of dividing them, we wind up aggregating them. We take multiple servers and we combine all of the resources within it and create a larger software-defined server. The other way of looking at that is for us to say, we're actually not slicing up a server, we're slicing up a data center. And again, we're no changes to the operating system. We can create servers of any size, and we're able to grow to meet the data requirements. And we have a lot of partners and customers have really joined us on this journey. This slide I like to point out is kind of a technical overview of what are we bringing to the party. And again, shortly after this, we're going to jump right into the SAP use cases where the rubber meets the road. Fast, there's no doubt. In-memory performance, that's the entire game behind SAP HANA. That's why you're here. So we get why that is happening. The real-time machine learning, that's how we solve the problem of keeping everything in memory. And again, I've got some deep dive slides on that coming up a little later. Easy. One of the things nobody likes doing is sharding their data. No one likes this to scale out systems. They're complex, multiple points of coordination. What we like is a single OS with a single point of management using our standard tools. And that last point, the shortened sizing and procurement, that's entirely what we're going to discuss for this webinar. Agility, scalable, the ability to take your system and make it as big or as small as you need it when you need it based on your business requirements, and the ability to adapt on the fly. Don't have to go into the data center, pull physical books or put plugs in. Everything is done via software. And it can be done on cloud or on premise. Again, we are a hypervisor. We sell software. We do not sell any sort of hardware behind our solution. And so you can take our licensing and you can move that around as you need, whether it's in your data center or if you would decide to move from your on-premise solution to a cloud, you can take our licenses with you. We're built upon cost-effective x86 servers. So we're not running on any custom ASICs. We're not running on anything, InfiniBand or NumaLink. Everything you have in your data center today is what you need to deploy our solution. And in fact, whenever I go out to a customer installation, it's almost never that they need to go get new hardware. They have everything you have everything you need already in your data center. And because we don't have any changes to the operating system, no special kernel, no special device drivers, we don't have to modify the OS, and our applications run exactly the same as they would on any other operating system. So if that's kind of the technical setting, this is kind of the intro to the business setting. What we've seen is if I'm going to purchase a large custom system, a traditional scale-up server versus a software-defined server, what I'll find is to actually do the sizing is going to take me 3 to 6 months. And we'll talk about how we do that, but we're going to go really deep in and try to figure out what are we going to need. Once we figure out what size we need, we're going to go and procure that. Might run an RFP, we're going to talk to multiple vendors, maybe a proof of concept. Then they have to go make one of these unicorns and ship it to us. And that's going to be 3 to 12 months, depending on where you are in the world and how global availability is for these servers. Once you buy that server, you're stuck 3 to 5 years. You're going to have that thing for a very long time. So you better not make a mistake. Meanwhile, down below, TidalScale, you can go out, get a commodity server, x86 server, take a node size to start with. And you can begin your implementation. You can monitor that, see if you need more or less. We've had customers who have actually over-provisioned, and then they can actually, right size that and adjust it as you go. Your production commit is mere weeks, basically until your next maintenance window, whether that's weekly, quarterly, monthly, whatever it would be. So when you add those all together, what we're looking at is the time from I want to start a project to the time where I am actually executing that project can be 25 times faster. So if I look at TidalScale for HANA, why? Why is it a solution? Again, for the most part, if you're going to be running HANA, you're going to have everything in memory. Sure, you can use native storage extensions and offload some of that. But if you really want the ultimate in performance, you're going to want to have everything in memory. And again, that can be very large, very quick. So you're going to need large memory. You're going to want to do it on a scale-up system. Most customers we talk to don't really want to go after the SAP scale-up solutions. And then, once you do this, you have to be able to adjust it as you go. Your business changes, so does your server. Speaking of servers, one of the things I do want to talk about here is I'm going to be talking about a software-defined server, but it is not just a single software-defined server that I'm discussing. I am looking at the entire landscape here. So when you start looking about, when I talk about a single server, I want you to think about all the different ways that your landscape requires servers, production, quality, development. These are just kind of your start, where everyone has to start. And this is, I would say, table stakes for what you need to have an SAP implementation. However, your test sandbox, your high availability, disaster recovery, a lot of customers want to have the exact same size. They want to have the exact same equipment, but they can't afford it. If my production system costs $1.2 million, or if it costs $200,000, am I really going to take that 3, 4, 5, 6 times? So keep in mind that anything you're looking at here is going to be amplified by the size of your landscape, not just for ERP, but for FBW, CRM, whatever you're looking at. As we begin looking at scaling, one of the big differentiators we have is that as you get larger with a HANA system, you can grow your system, but as you grow that, the terabytes, every terabyte gets more and more expensive. So one of the biggest problems is as you jump from 2 to 4 to 6 to 8 terabytes, as you get into those larger systems, you find yourself growing logarithmically for a traditional scale-up system. Whereas on a software-defined server, you can keep that linear growth. And therefore, it actually is more efficient to grow larger systems. Whereas before, we didn't want to consolidate. Before, we wanted to have as many small systems as possible. We can now get economies of scale by keeping the cost per terabyte growth as a linear function. One thing I'm going to jump on here and just point out is that a lot of people will ask how big of a system we can make. Quite frankly, we actually had an analysis done. We're bound simply by the ability of Linux to address. So we did an analysis, and our architecture can scale to exabytes. Now, frankly, we're not trying to go there quite yet. That's a little larger than most people need. But we are bound by what Linux can address, not by what we can put into the solution. So let's talk about sizing. Okay, so perhaps some of you are already running a system, perhaps some of you are looking at starting a new system. So we're going to start with, assuming you already have a system and you're running, we'll say SAP on Oracle or SAP on MS SQL. What you could do there is brownfield sizing. And SAP has 2 ways of doing that. The first is the quote unquote quick and easy, where you basically just divide your database in half, add 20%, little fudge factor. And they also recommend 50 gigabytes, but at that level, 50 gigabytes is nothing. And that'll give you kind of a rough idea. That's probably not good enough. So SAP has sizing reports. So you can run these within your system. You can run those at various levels of granularity, and you can get a fairly good idea of what your system is going to look like. So you can see here, I ran a sizing report with a customer, and it's telling their installation, their initial installation is going to be about 4.2 terabytes. Or 4,200 gigabytes. That's not bad for the initial sizing. But what if you're a greenfield? What if you're coming off of a completely separate system. So Oracle Enterprise, EBS or something, or JD Edwards. What you can do then is there's two quick ways. One is use the quick sizer, and you can say, well, how many users do you have? Now, not all users are equivalent. Some users are punching in sales order 70 times a day. Some are punching a sales order 5 times a day. So you're going to kind of get a very, very rough estimate based on your users. You can also go through the throughput. Well, okay, how many line items do I expect per sales order per day? Again, you're going to spend a ton of time and a ton of money, and at best, you're going to get a rough estimate. The other way of doing it, and this is actually on the SAP sizing website, it's you can do a trial and error. So you can do an expert sizing or a custom-based sizing, and that is basically run part or whole of your entire sizing, which is the Nike methodology. Just do it. You want to know how large a system you need? Just create one. And that's often easier said than done. Again, looking at the customer above, they're going to need a 4 terabyte system. They're probably not having a 4 terabyte system just sitting around their data center. So to do that sizing in the just do it methodology requires them going out and getting a server specifically to figure out how big of a server they need. Not really ideal. So when you do the real field sizing, that even after spending all that time and all that money, usually what you wind up with is a fairly inaccurate solution. So you've done your best, but it's no better than really putting it at a dartboard. For example, throughout the webinar, I'm going to bring out actual customer examples. We had a $20 billion retailer that we were working with, and they were taking a Teradata extract, and they were going to put that into their SAP system. They figured out using the trial and error method, or actually the guessing method, I would say. They needed about 12 terabytes. So they looked out, and their options were a huge bull system or TidalScale software-defined server running on 4 3 terabyte servers. So we ran the proof of concept, and as we're running the proof of concept, we figured out, wait a second, we're only watching about a little over 5 terabytes of data. We went back to the customer. We said, using our monitoring tools, we don't see 12 terabytes. We see less than 6. Customer did an analysis, and it turns out, no, you're right. We don't need a 12 terabyte system. We can get by with a 6 terabyte system. So at the end of the day, they pushed 2 servers. They went back into their data center, and they wound up, if you look at the difference between what they thought they were going to have to buy, 2.4 million, to what they actually needed, 638,000, that's 1.7 million difference per system, just for one system. For example, let's say that's your sandbox system or your dev system. So that's one of those cases where your sizing, could be rather disastrous. And from a system sizing situation, TidalScale is fantastic. You can go take servers that you have sitting around, you can create a large server, you can do the trial and error, and you already have all of that hardware sitting there. So this is a great use for TidalScale to kind of do that trial and error system based on components you already have in your data center. Now that's just covering the system installation. That is, how big am I tomorrow, the first day I turn my system on? Everybody has to try to figure out, what is the future growth, right? Oh, it's going to be 10% per year, 5% per year. And when I say future, they're looking 36 to 60 months out, so 3 to 5 years. Usually it matches up with our depreciation schedule. And I like to point out to people, think back 6 months ago. Did you think you were going to be where you were today? I don't know if you're like me, I'm working from home and not from an office. 3 years ago, 5 years ago, no matter what, you cannot predict the future. And we all try, but you can't. Things happen in business, things happen with the software, things happen globally in the global economy. For example, like the COVID epidemic, pandemic that we're part of right now. So what happens? How do people react to this complete inability to view the future accurately? So they oversized. Pretty much says, I'm just going to go out and buy the biggest thing I might need, plus 20%, and I'm going to go big. CFOs hate that. CFOs hate finding that an entire budget has been just blown on a system that could be twice as large as it really needed to be. What's your other option? Other option is CFOs and CIOs hate when you buy a system that's too small. If you buy a system that's too small, and in 2 months you wind up having, okay, great. my system's now too small. I need to go buy another. So not only do you have to buy a bigger system, but you've already spent money on that smaller system. So they absolutely detest that. So what we've seen most of the time is HANA servers are really big toasters. Customer thinks they need 9 terabytes. They put 9 terabytes on the floor. Turns out they only need 3. 6 terabytes of money just burns in the data center. There's a better way. Let's watch and see. We're going to just take a TidalScale server, a software-defined server. We're going to run through kind of a quick, we'll say 2 years in the life of a TidalScale server. First thing we're going to do is we're going to system install. We did our best. We did our best sizing exercise. We did our system installation. Right after we do the system install, we have to load all the data. Now, again, if you're coming from another large system, you may have 5, 7 years of data. You're going to have a huge amount of data, but you're limited by your ability of the RAM that you have today. Well, wouldn't it be nice if I'm doing a huge data load just for a week to add a server into my software-defined server, add an extra 50% capacity, do that large data load, avoid my delta merge process that really can eat up a lot of memory and a lot of time. And after I'm done with that, I can go back to my normal operations. Again, couldn't do that before. I'd always have to buy for the peak. I run with my normal operations for, let's say, 9, 10 months. All of a sudden, wow, things are going a lot faster than we imagined. I'm starting to get a little hot on space. I'll just add another server and I'll keep on going. Now that's fantastic. We all expect organic growth. One of the things we don't expect is a rollout, acquisition, new modules, something occurs. Working with a customer earlier this year, they had spent 7 months doing a sizing exercise. They knew exactly how large the system needed to be. They knew exactly how large the server they needed to purchase for that system. 2 days before we went on site to meet with them, their CEO announces a $3.2 billion acquisition of one of their competitors. Their entire 7 months of analysis is out the door. Sure, they knew exactly what they needed for tomorrow. They knew what they needed to install. But when they started bringing in that acquisition, they knew it was never going to fit. So, no matter how far ahead of time you think you can see, things happen that you need to adjust to. One of the things that you may or may not think of as an adjustment, but hopefully, and I pray you're all doing this, is in addition to rolling out new functionality or expanding it, roll out to globally to various geographic regions, there's patching, there's upgrades, whether those are for security or functionality. So I'm going to look at a traditional system. We've all seen this 100 times. It's our development, quality assurance, and production landscape. We're writing code in development, moving it to QA and testing it, then moving on to production. All of a sudden, we need to upgrade. Okay, I need to test that upgrade. What am I going to do? I need to go out, I need to purchase another development system because I'm not keeping a huge specialized system around. So I go and I buy a development system the exact same size. Sometimes people use this as a ability to copy production back. I want to work on real data. I want to see what's going to look like when I get there. Might as well refresh the data. When I do a quality assurance copy, I'm almost always taking a copy of production. Again, I have to go out and get additional hardware. People who've been doing this for more than a few months will recognize this as the traditional 5-box landscape. Once I've upgraded my new development, upgraded my new quality assurance, I'll upgrade my production system. My production system is upgraded. Once that's done, I cut on over and my new maintenance landscape is created. I've got an old development and quality assurance system sitting around. These are very specialized HANA-specific equipment. What do? They sit there and they burn through depreciation. People try to find other reasons to use them. And everybody says, oh, I'll find a way to use them. But at the end of the day, you may not want them, and all they're doing is just sitting on your books. The other way of doing it, and we'll go through a little faster, is I'm going to take my TidalScale systems. Again, I'm using commodity 2-socket servers that I have hundreds of in the data center. Maybe only 50, maybe 300, depends on the size of your data center. So when I need to go get a copy of development, I can create a system of any size to match whatever size data I want, whether that's development or production. Exact same thing. I'm going to use standard servers that I'm using throughout my other projects. I'll put those together, create a quality assurance system that matches the production size, and then I'll upgrade my production system. Everything's exactly the same so far, right up to this point. Now, I'm facing the same issue. What am I going to do with those servers? These are the standard servers, the standard 2 and 4 sockets that I've got throughout my data center for all my other projects. All I do is I'll just put those back into my data center. Those can be used for other projects. They're standard servers. So one of the things I often have people tell me is, God, this is fantastic. I really love this. This is great. But I don't need a huge server. My point is that a lot of customers, when you look at it, one of the things you can do to save a lot of money, and not hardware, but process-wise, is a server consolidation. For example, if I take my development system, I may have tons of small HANA containers. These are multi-tenant database containers, MVCs in the SAP world. And I may have lots of those. Now, if I look at a traditional environment, I'm going to have a server, I'm going to have an operating system on that one server, a HANA database, and I'm going to have an MVC. And I could have one or more, and you can think about those are just small databases. And I have multiple operating systems, multiple HANA database, and I have all of my databases, my MVCs on them. We find that the HANA database and operating system, this is where a majority of the costs are for patching, monitoring, disaster recovery. Basically, you're burning a lot of manpower and a lot of labor. Wouldn't it be easier if we can consolidate those on a bigger server? And again, why haven't we done this in the past? In the past, a larger server meant logarithmic cost. Currently, we're looking at a larger server is linear cost. So I'm able to put all of those resources together, put a single operating system on top of them, and I have a HANA database encompassing all of my needs. And I have everything is now single. I have one operating system, one database, and I can save hundreds and hundreds of points of maintenance. Now, some people will say, wait a second, I'm putting all my eggs in one basket. True. In the past, this was a problem. So if I wanted to go take that basket, and again, I'll take an example. If I have 5 MVCs here, traditionally, if I wanted to if I wanted to upgrade the system, I need to back up the whole system, upgrade everyone at once, and if it worked, great. If not, I had to restore the entire system. Massive outage. And I always like to think of these MVCs as 5 complete separate divisions of a company, which is the worst case scenario. I need to get 5 groups of business users to all agree for downtime. Never going to happen. Well, we don't have to worry about that anymore. The other way of doing it was I take and I buy another system. So I have to buy an entirely new system and I upgrade one at a time. It takes twice as much hardware. What if we could do it this way? Take one of my servers, and I'm going to create a brand new software-defined server. And I'm actually going to upgrade my operating system, upgrade my database, and when I'm ready, I'm going to take my first division and say, are you ready to upgrade? Great. I'm going to move that MVC into my new environment. As HANA is fantastic, and then it automatically upgrades for me, and I'm good. Well, what if it didn't work? I can fail right back. I didn't destroy my existing environment. So I can take the first, I can take the second. When I take the third, I'm going to need a little more horsepower. So I'll take a node with me, add a little more horsepower into the new system, and I'll keep doing that until I've slid everything over from the old environment into the new environment, and I'm back with the exact same amount of hardware that I had before. And again, one of the things that we can bring to this is that the ability to take a server and create multiple different sizes out of it, slice it up as we need. So one of the things that people ask me all the time is that's great, I'm going to use this as part of a TDI solution. How do I know it's going to work? How do I know it's going to be performant? So one of the things we do, and the thing I first recommend any customer, is take your HANA hardware and cloud measurement tool. So this is the follow-on to the HWCCT, the HANA hardware compatibility check tool. It's hard to say fast. And so basically you run this, it takes a few hours to run, and what it does is it investigates all of your operating system, your underlying hardware, the capabilities, network and disk, CPU, and it goes through and it makes sure that everything meets the SAP performance and requirements to run HANA. We have run this on hundreds of systems. So we've run this on NFS, iSCSI, SAN, Lenovo systems, HP systems, Dell, anything you can name it. Even systems that I can't even pronounce that we've run across in some from various remote areas. And we keep passing these. And again, this is the first thing you're going to want to do to make sure that you've got a system that's going to work. And again, we've got hundreds of successful implementations and results from these HCMT tests. Speaking of which, so talking a little bit about performance and scalability. One of our customers, SK Hynix, they had an existing HP Superdome system, and they were looking to replace that, so they needed a new one. So their choice was to buy another HP Superdome because of the scalability, the ability to make it large, right? Or to switch over to a software-defined server. So again, kind of the same solution, but two different methodologies to doing it. One doing it in hardware with a custom ASIC, the other doing it in software with an inverse hypervisor, as we call it. So when I look at this, they took their system, they copied their current production system on top of a software-defined server. They ran the top 6 queries, the top 6 transactions and batch jobs, and turns out that we were 44% faster than the existing Superdome system. The big takeaway here is that we were actually significantly cheaper. Again, the fact that the performance was there was excellent. We love that. That is not what we're going for. Again, we're looking at a very flexible, cost-effective solution for meeting the HANA needs. So now that we've seen what we can do with it, let's talk real quickly about how do we do this. So this is kind of the technical deep dive. What we do is if I have 4 bare metal servers and I have all the resources, and you can see these servers are connected by Ethernet, but they're physically separated. And when I say Ethernet, this is going to be 10 gig or higher Ethernet is our requirement. When we boot our hypervisor on type of all of those servers, so we'll PXE boot those, and what happens is we create a software-defined server. And that software-defined server aggregates all of the underlying resources, presents them as a single server to the operating system, and therefore is addressable by the application, in this instance, SAP HANA. This virtual CPU is allowed to access any RAM. This virtual CPU can access any I/O. Let's play a day in the life. So what happens when we start using the system? So if I boot up my HANA system, in the first minute, this virtual CPU is going to try to get a page of RAM. Say we're going to read GLPCA. Underneath, what I'm having is this thread is going to try to access RAM from this server. Up above, it's perfectly acceptable. The operating system sees no difference between any of that RAM. But underneath, this thread and this RAM are physically separated. Inside the inverse hypervisor, we have our machine learning. And that machine learning will copy the system, the RAM over, and then we'll continue on our way. And the machine learning says there's a relationship between this thread and this RAM. Again, we'll copy if it's a read, we'll move it if it's a write. And what happens is as HANA goes through the column or partition, it'll collect everything together, and we create that what we call a working set. Now, that's the entire point of what we're doing here. So what we're trying to do is figure out the spatial and temporal locality of those pages of RAM. We can't see columns, we can't see tables, we can't see schemas, but we can see threads that access pages of RAM in an ordered manner. So we're going to skip ahead. We'll say it's 3 minutes later. This virtual CPU goes to access a page of RAM from another. Let's say it's VBAK. We're going to look up sales orders. Now, at this point, the same issue occurs. I have a thread that wishes to access RAM on a separate server. However, I'm not able to copy that over. That RAM, that one page of RAM, is now in a working set. That could be, say, 10 gigabytes or 20 gigabytes of RAM. And I don't want to have to copy all of that RAM over. So when server 1 requests that one page, it won't be able to copy it over. Instead, it will say, I'm going to stop my execution on this thread. That's one machine cycle. I'm going to move it over my 10 gig or higher network in a single jumbo frame. And then another machine execution, so one machine cycle, and I'm back running. And it looks like a virtual to physical memory miss is what that looks like to the operating system above. So what we're looking at here is that as we go along, the operating system is basically telling the below servers what it needs, and the machine learning is making sure that everything is placed local so that the fewest number of hops and the fewest number of moves are made. So one of the questions we get a lot is, well, what happens if one of those systems goes down? What happens if one of those servers go down? Again, we're looking at 2-socket servers. Those 2-socket servers are extraordinarily high availability. So they make millions of them. They're made in greater numbers than any other type of server out there. But things do happen. So what we recommend is you're going to have your standard primary database server, and you're going to be doing HANA system replication to your second database server. So if you have a highly available system, you're going to do the exact same thing as you're doing today with software-defined server. What I'm seeing there is that when I do have a failover event, that primary database, whereas it might take me days or even a week to get a very large, what we call a unicorn, so an extraordinarily large, say 16 socket server, we're running standard 2-socket servers. So when they do have a failover, I can just grab any other server that I have sitting around, maybe in my test system, maybe on a sandbox system, or just any one of the hundreds I have in my data center, and I can copy that over into the primary database server, and I can bring that back up. So the ability to repair the system using standard components is extraordinarily fast. So one of the things I want to do now, and again, we've kind of covered a lot of things, is let's talk less and show more. So what I can do here is I've got a copy of my, this is called Wave Runner, and our Wave Runner is very similar to the vCenter. So this is going to be our command and control, where I can bring in nodes, I can copy systems and create servers. So what I'm going to do here is we have pools. Now pools can be thought of as a collection of nodes, and in these pools I have various different, I have my EMEA non-production, South American non-production, and I'm also running some software-defined servers. Now what I want to do today is if I'm going to take, let's say I have a France, this is my my France human resources copy of production. For some reason, okay, I have 3 servers in this, and I want to actually create a copy of this system. Okay, well, it's running in my EMEA non-production. Well, if I look down here in EMEA non-production, I only have 1 extra server that's not being used. Okay, not a problem. So what I need to do is I need to go out in my data center and grab 2 other nodes. So I'm going to go out and say, I'm going to grab 192.168.1.1. I'll say 3 other nodes. I'll log into my BMC. I found 3 nodes. They've all answered my my login, and then I'm going to configure those nodes. And all I need to do is I could go through and I could configure all of the network information. But since I've already got other servers I've used in the past, I'll just copy the configuration to those 3, and I will bring those in. As I bring those in, you'll now see I have multiple 4 new servers. I'm going to create a copy of that system. So I'm going to go create, now that I've got enough nodes, enough server capacity, I'm going to create my software-defined server. And I'm going to say additional prod copy of France HR. Going to use a modern operating system. I'm going to select all those nodes. Oh, you know what? I only needed 3. I'll throw 1 back. I'm going to say I need, I'll use 2 terabytes of disk. And I don't have SUSE located on my laptop, but I'll use OpenSUSE. I would recommend using SLES 15 for SAP. And now I've got my additional copy of my server, okay? So what I'm gonna do now is I'm gonna turn that server on. When I do that, I'm actually gonna take all those servers will power on at the same time. So rather than have 1 large server boot up, I'm gonna go through all servers at once, and they're gonna all boot in parallel. Again, this happened very quickly. These are mock servers in my demo environment, and they've got 2 great qualities. One, they boot very quickly, and they have 0 cost behind them. Once my software-defined server is up, I can then turn on my guest, and my system is up and running. And again, in the real world, this takes about 5 minutes. And the only difference is the amount of time it took for the fake servers to boot versus the mock servers versus a real server. So in a real world, probably about 2.5 minutes for those to boot. So when we say that you could literally create a new server in 5 minutes, this is exactly how you would do it. And this is the exact tool you would use. So now that we've had the demo, what are the other SAP use cases we have? So many of you may be looking to go to HANA. Again, if you're looking at SAP sizing, you're probably on a non-HANA solution right now. Some of the ones that we've seen have been extremely helpful. TidalScale is Sybase, Oracle, and SQL Server. And again, I'm going to point out most customers have their SAP database licensing included as their user-based runtime licensing. However, there are, I'd say, 5 to 8% of SAP customers who, rather than using an all-encompassing runtime licensing, they prefer to do a, let's say, enterprise agreement, or they do core-based licensing. And so what we've seen there, especially for some Oracle customers, and Sybase as well, Sybase 16 has switched over to being core-based, is they're looking at taking a server that's now 4 years out. So today, they look out 4 years to their sizing. They take the possible system that they might need in 4 years. They add 20% of that. Again, we've oversized the system. I take that oversized system and I come back to year one, and I'm going to purchase that today. So again, let's talk about Oracle, because I think Oracle licensing is probably the most discussed. So rather than buy the system I need today, I'm buying what I need in 4 years. And I like to call that, I'm buying the prom dress for my 5-year-old. I think I know what I might need many, many years out, but I'm going to buy it today. When I buy that system for 4 years out, I'm taking in all of those cores. I'm taking all of the memory. I'm taking everything that I need today that I really am going to waste. And again, theoretically 75% of. Those cores in a core-based licensing situation are very expensive. I'm going to pay for every single one of them today. I'm also going to pay maintenance for them. And I don't just do that for the first year. I'm going to pay that maintenance for every single year. I'm going to pay for those well in advance. The other ability to do this is we can use TidalScale. What I can do there is I can look at what I need for the next 6 months. Again, it could be to your next maintenance cycle, your maintenance window. Let's say 6 months. And what I'll do is I will buy the CPU and RAM that I require for now, and I will license what I need now. And when I grow in a year, I can reassess my business requirements, and those business requirements may say that I need to buy more. I might be able to put it off for another 6 months, but I can grow every year as I need. And at the end of the day, when I look at the fact that I haven't paid maintenance costs that I didn't need to, and that I only purchased every single license that I needed when I needed it, my overall savings can be absolutely incredible. So, and again, we've seen this for multiple databases. When it comes down to it though, there's a little bit more besides just the core-based licensing. So if you're one of the main runtime users that have all of your licensing encompassed with your SAP end user license, what we did is we took a bare metal server. Okay, you can kind of think of this as your current SAP system. This is your SAP system running Oracle today. And that system is going to be running with as much RAM as you can fit with your SGA, your PGA, your data buffer cache. What we did is we went and actually got some other servers, but we took 2 extra servers and we doubled the RAM. Okay, and what we did there is for the SAP system, we ran multiple tests. And I want to point out 2 things. One, this slope going down. Because that machine learning, when we first start the system up, it is working on creating working sets. It's organizing the data. So what you'll see for all the TidalScale implementations is a period of learning. It's a very quick but noticeable learning, because what we're doing is we're organizing our memory, and then all subsequent transactions are going to occur on a single server with perfect bandwidth, or QPI bandwidth. That memory bus on every single server is completely optimized. What we saw is that I could grab doubling my memory. The performance was 2.5 times faster. When I was able to take I had additional memory available, I was able to take that memory. I was able to turn on the Oracle in-memory option. Now, this is a slightly more expensive Oracle feature, but turning that on, I was able to get a system that was extraordinarily fast. Now, it was not as fast as HANA. That's one of the, now again, a lot of SAP time has been spent optimizing the SAP HANA experience. So, a lot of transactions have been HANA optimized. So this is quite acceptable that you're not going to get as fast as HANA. But what's really important to know here is that we're able to take an SAP on Oracle system and basically put the entire thing in memory. Now, what's lovely about this is that I can now take that server that I'm running SAP on Oracle on. And when I need to go and I want to go SAP on HANA, I can use the same hardware, as opposed to if I went out and I got an Oracle Exadata system. At that point, Oracle Exadata is not going to run HANA. It is designed for running Oracle Exadata. So what we're looking at is we're talking to customers who they're not quite able to go to HANA yet, or for whatever reason they can't, the business can't do it, but they're looking to get prepared to go to HANA. And this is kind of a nice stepping stone on the path to HANA. And I hate to do it, but I have to make the pun. It's a stepping stone on the road to HANA. And we've all heard the road to HANA joke 100 times in the last 10 years. So how's that possible? Well, when I look at the server where we did not have, when we had half as much RAM, what we saw was, and this is my Oracle Enterprise Manager looking underneath, I see a lot of CPU usage. And what I'm seeing is it's all this blue, and that's I/O. So essentially, I'm going out to disk. This disk happens to be NVMe. But no matter what, I'm still pulling in a lot of disk I/O, and that disk I/O is slow. And again, in the world of SAP, your disk I/O has got to be under 10 milliseconds. That's just table stakes. But you're going to want it to be really under 1 millisecond. But even under 1 millisecond, we're doing a ton of I/O back and forth. And again, whether we do this with HANA or we do this by putting the entire Oracle database, or as much as possible, if we put it in RAM, what we then do is we get rid of all of that I/O. Even though it's a 1 millisecond, a few billion of those kind of add up. A billion milliseconds takes a little while. By putting everything in RAM, we get that in-memory performance. And one of the big differentiators, the difference between going to disk and going to RAM. If I'm going to disk, it takes a long time, and we all know that. In human terms, I can think about it this way. If I need to stop my execution of my CPU and go to RAM, there's a delay, and it's like 30 minutes in the human terms. So it's like calling your spouse and saying you're going to be 30 minutes late for dinner. Conversely, if I have to stop my execution and I have to go to disk, it's like calling your spouse and telling them that you're going to be a year late for dinner. So to put it in human terms, one of them, your wife or your spouse, my wife in this case, would be a little upset. If you're a year late for dinner, you're probably going to find the doors, the locks and the doors changed, and you're not going to come home. The last use case is analytics, right? So there are many customers who use HANA as just a database. So no ECC, S4 HANA, BW. What we're looking at is a pure data analytics. So one of our customers, Mohawk Carpet and Flooring, this is the world's largest flooring manufacturer. What they did is they're using HANA as a database for their analytics. They're looking at replacing their current 4-socket systems. And what they actually had is they actually had a couple of systems that were sitting on the dock. These are older systems that were about to be retired. They were on the dock going to be returned to the reseller. And what they did is they copied their 4-socket system onto a TidalScale system. And again, there's 4 of them here. And the only reason why there's 4 is these only had 256 gigs of RAM, because these were, I don't want to say throwaway, these were about to be disposed. And the results were fairly shocking. We were able to load everything in RAM with, again, we had more memory buses here. We're looking at single memory buses versus multiple memory buses. And we saw that the current hardware versus the TidalScale software, we were able to create a faster system. And again, this wasn't about performance. This is more about, I'm able to run HANA on disposable hardware, and the cost is almost nothing, right? Now, going into production, we're not going to use disposable hardware. However, it just shows you that you can literally tie together systems that are sitting around your data center, and you can get incredible cost savings. But you don't need to take it from me. You go on our website under resources and videos, you can actually find Jonathan Yadin from Mohawk, their CIO. He was on stage with us in December at the Gartner Infrastructure Operations and Cloud Strategies Conference, back in a world where we actually had conferences we could go to. And it's about a 2-minute video. So if you have a moment, I won't play it here, but I do recommend you going and hearing this story in their own words. Speaking of Gartner, at that same conference, the keynote presentation, and we grabbed the screenshot with permission from Gartner. basically they had three huge tenets, and those tenets were that your infrastructure needs to be programmable, which I think I've shown fairly well. We have quite a programmable, customizable server infrastructure. We do have an API. We have, in addition to the GUI that you saw, so we can actually be programmed as part of your orchestration. Modular, we fit in very well with the rest of your data center. We're looking to do one thing and do one thing well, and that is to be the last piece of the software-defined data center. And last is intelligent. And again, we are the first instance of using machine learning below the operating system layer. So we appreciate Gartner giving us those plugs because we think that those exactly what we needed to our audience to hear, and we meet those quite well. So at the end, you have to ask yourself one question, or maybe 9. Does your system meet the requirements you have today, tomorrow, the future, and whether that future is known or quite tumultuous? So we like to think, like to end with a quote by Gordon Bell. Gordon Bell was the father of the microcomputer, the VAX, the PDP, and an early investor in the TidalScale concept. And Gordon said, "This is the way that all servers will be built in the future," and we agree with him. And I agreed with him enough that I quit my job after 3 weeks and started doing this. So I hope I've shared some of that passion with you. That's our presentation. We've reached the question and answers section. So if you could at this time, if you have any questions, you can enter those into the GoToWebinar control panel under the questions section. And Juhi will read those out to me, and I will, we've got about 8 minutes. I'll try to answer as many as I can. Thank you very much.
Thanks, Eric. So we have our first question, and it is, can we add capacity on the fly, or do we have to shut down our system?
Good question. So today it is a, you have to do a restart. So you do have to reboot your server in order to pick up the new capacity. So you could just do that at your next maintenance window as required. That being said, that is on the roadmap for us to do a hot add, hot remove, but that is not in the current version of the software, but it is definitely on the roadmap for the ability to hot add, hot remove.
Okay, the next one is, SAP has spent an immense amount of time making HANA NUMA aware. Wouldn't your software fight with the SAP logic?
Good question, very good question. So yes, at first, so what we did have is that our software, again, what our software watches the operating system above, and we have no concept of what it's asking. All we're doing is we're looking for patterns. We're watching patterns of access. We would take all those memory accesses from HANA through the operating system to the inverse hypervisor, and we would do our best to place things where we needed in the past. What we have done recently is we have created a NUMA awareness to the TidalScale inverse hypervisor. So what we are able to do now in recent version of the TidalScale software is we're able to expose a NUMA domains up to the operating system. So in past versions of the software, 3.1 and below, we basically showed a single NUMA domain, and of course HANA saw a single NUMA domain. In newer versions of the software, we're now able to pass as many NUMA domains as we desire, and that basically allows SAP HANA, or the operating system, and therefore SAP HANA, to see multiple NUMA domains. And at that point, rather than kind of working against each other, we work hand in hand. That's a huge point of performance. So the two softwares kind of meet in the middle and play together much better. That's a great question. Thank you, whoever asked that.
All right, the next one is, are you certified by SAP?
So at this time, so we are approved for use for non-production by SAP. We are working with SAP for certification for the production levels, and again, we work with that. We're as fast as we can. We're trying to get that certification. We do have a very rich history with SAP that I didn't mention. One is that, so SAP is an investor through the SAP Sapphire Ventures investment arm of SAP. So they're an investor. Additionally, our founder and CTO, Ike Nassy, he's the former, let's see if I get this right, former head of research for SAP. So he was there 10 years ago with Hasso working on HANA. He actually retired and was sitting around one day and thought, oh, there's a better way of doing this. The actual company was founded by Ike having a better way of how to do HANA. So yeah, that's pretty much there in our HANA is in our blood. So great, thank you very much. Good question.
All right, the next one is, do you have any best practices for sizing an SAP system for TidalScale?
So two different, well, we kind of covered the brownfield versus greenfield. We have a document for sizing in-memory databases that would be for SAP, Oracle, and we're working on adding Sybase to that as well. What we like to do is look at, and I hate to say it, we take that rough estimate. What we do is we figure out what is the best node size. So what's the best underlying server? I don't want to have 256 gig servers. That's quite wasteful and makes our machine learning work very hard. What we see for most customers is they start with 768 gig systems, 1.5 terabyte systems, or 3 terabyte systems. We're working with some customers who are looking at starting with some much larger 6 terabyte systems. But so what you're looking for is to start with a system today with a node size that allows you to add probably, maybe 3 or 4 times in the next 5 years. So you don't want to add 100 nodes, but you also don't want to add just one. So we actually do have a sizing guide that we can pass along and work with people. And again, the nice part is that once you come up with a rough estimate, if I have a 768 gig system, I can create 768, 1.5, 2.3, 3. I can just start adding nodes, and I can actually grow my systems fairly well to cover whatever sizing is my eventual needed capacity. Okay.
Okay. If we have a support issue, what do we do?
So for support, I'm assuming you're saying SAP support, so I'll just answer the question if you're running an SAP system on TidalScale. So if you're having an issue, we've got a support contract and support desk, and that can be, you can log a ticket through phone, email. We have a web front end as well. And again, I tell customers that we've got SAP knowledge in house. Basically contact us. We will work with you, no matter what, and help you ascertain what that is. If it is an SAP issue, for example, for some reason, I don't know, Hungary's getting the wrong tax code. You would still go that through the SAP support portal. But for anything on the side of the software-defined server, we're definitely recommending you contact us, and we will help you in any way possible to help you get to the solution.
And it looks like this might be the last question that we have time for, Eric. Have you thought of any of the security concerns?
So our chief engineer has done some government level security, some work. So he is a very security conscious person. One of the things that we actually do enjoy from this level of virtualization is that there is no such thing as a nosy neighbor side attack. When I take a server, and again, so imagine I create a software-defined server out of 3 nodes. So 3 servers connect together to create a single software-defined server. All those resources are passed up to a single operating system, a single application, and a single corporate end user. So from that standpoint, it's not like I have a traditional virtualization where I may have multiple companies on a single piece of hardware. So some of the side attacks you get, for example, Spectre or Meltdown or some of the more famous recent ones, those are those are alleviated with this this architecture. Lastly, the network that we have connecting those systems together, that is exposed only behind the physical servers. So that's not, that's a completely separate isolated network. So again, we're not looking at any chance of sniffing or you know, any other eyes. It's all held well below the operating system layer. So, but yeah, security is actually quite improved with this level of virtualization. Great. Thank you very much. Julie, is that it, or we're good? I think we're out of time.
That's good. So for those of you that we didn't get to your questions, we'll definitely be in contact over email. And when I end the webinar, if you could take the time to answer the 2 quick survey questions, that would be great. And thank you everyone for attending.
Thank you everyone. Have a great day.